So we will start using the trigonometric circle in order to find different values for sine, cosine, and tangent. So if you remember when we did the trigonometric circle, the radius is 1. Therefore, when you start here at 0 degree or 0 rad, the coordinate of your point is 1, 0. If you go to pi over 2, which would be here, pi over 2, this is 90 degree. The coordinate would be 0, 1. If you keep going 180 degree here, then your angle is now pi, and the coordinate would be negative 1, 0. And the last one at the bottom, which is 270 degrees. If you think about pi over 2, that is up here, pi over 2, 2 pi over 2, and this would be here 3 pi over 2. And the coordinate would be 0, negative 1. After that, we looked at the 30-degree angle here. This one here was 30 degree. Imagine this angle here. How many of that one would we have in our pi? We would have 6 of that one. So this one here is pi over 6. And if you remember, when you have an angle of 30 degree here, the opposite side in a triangle, if you imagine that we have our right angle triangle here with our x coordinate and our y coordinate, opposite the 30-degree angle is always half of the hypotenuse, and the hypotenuse here is 1, so therefore our y coordinate is 1/2. And if you remember the equation, if you use the Pythagorean theorem here, actually x squared plus y squared equals 1, you can figure out that the first part here would be square root of 3 over 2. And with the same idea, if we come to take this triangle here, if we take this triangle here, which has here 60 degrees, if this angle is 60 degree and it is a 90-degree angle here, then that one is 30 degree. And if this 30 degrees, the opposite side is half of the hypotenuse. Our hypotenuse is always 1, so that means here our x coordinate is 1/2. And again, using the Pythagorean theorem, you can figure out that the other one is square root of 3 over 2. And the last one in the middle, I will put it in purple here. This one here is pi over 4, because there's 4 of that angle that would fit in the whole triangle. And this one, using the Pythagorean theorem again, to use x squared and y squared equal, we would find square root of 2 over 2, square root of 2 over 2. So using these points, you can complete the rest of your trigonometric circle. And I'll give you a couple of seconds. I suggest you pause the video and you try to find the other angles and then go to the next slide. When you think your circle is completed, you can go and check it out using something like this. This one I took from the lumenlearning.com website. I think it's pretty nice and complete. So when you look at any of those points, you have to remember that if you imagine your triangle, let's say like this, that's a 90-degree angle with your angle in the middle in rad. You have your x coordinate here and your y coordinate, and your hypotenuse is always 1. So if you think about, for example, cosine of the angle would be adjacent over hypotenuse. So in this case, it would be x over 1. And so you can really write down that x is equal to cosine of your angle. And using the same idea, you can do the same with opposite. If you do sine of your angle, sine would be opposite over hypotenuse. So therefore, you find that your y value is always equal to your sine of your angle. So when you look at any of those points, the first coordinate always corresponds to cosine of your angle. And the second coordinate here always correspond to sine of your angle. My trick to remember is that they appear in alphabetical order. Cosine is the first one, sine is the second one. So if I'm asking you, for example, to find what is sine of pi over 2, then what you would have to do, you would go to pi over 2, which is up here. You would look at the coordinate, and sine is always the second coordinate, so sine of pi over 2 equals to 1. If you want, you can also check using your calculator. Make sure your calculator is in rad. Sine of pi over 2, make sure also you put this in bracket on your calculator. You should get 1. Now, what if they ask you to find cosine? If they ask you to find cosine of negative pi over 3. Now remember, negative means that when you start from here, you're going to go down, and pi over 3 would be around here. Negative pi over 3 is here. So if they want you to find cosine, cosine is always the first coordinate. So your answer would be 1 over 2, 1/2. What if they ask you to find tangent of pi over 6? Now, if you remember, tangent, I'm going to come back here, tangent is equal to opposite over hypotenuse. So tangent of theta is opposite, which is y, over adjacent x. Now, if you change that using sine and cosine, that means that tangent of your angle is equal to sine of your angle over cosine of your angle. So if you want to find tangent of pi over 6, you have to remember what are the coordinates at pi over 6. Pi over 6 is this one up here. So you have square root of 3 over 2 and 1/2. So if you want to find sine over cosine, that means you would do 1/2 divide by square root of 3 over 2. I'm going to use the space down here to show you what happens. So if you want to do 1/2 divide by square root of 3 over 2. If you remember what to do when you divide fraction, you can multiply by the reciprocal. So you can multiply by 2 over square root of 3. And in this case here, you have 2 on the top and 2 at the bottom, so you can simplify these two. So your answer would be 1 over square root of 3. But if you remember from the beginning of the year, what did we do when we had a square root at the bottom? We need to rationalize. So if you want to rationalize, you need to multiply by square root of 3 at the bottom. But if you do it at the bottom, you have to do it at the top. So it's like we're multiplying by 1. All of this here is equal to 1. So we're allowed to multiply by 1. So what happened is on the top, if you remember when we multiply fraction, we will multiply the top with the top and the bottom with the bottom. So on the top we would have square root of 3, and on the bottom we would have square root of 9. Now square root of 9, we know that is the same as 3. So our answer for tangent of tangent of pi over 6 would be square root of 3 over 3. So now using your trigonometric circle, you can use all those points around to complete the table here to figure out what does the graph of sine theta looks like or cosine theta. So I'm going to start doing the first line with you. How do I find sine of negative 2 pi? Remember, when we go positive, go that way. So negative 2 pi, we have to go that way and make a whole circle. And sine is always the second coordinate. So I'm going to start here by filling the table here. At negative 2 pi, sine is 0. At negative 3 pi over 2, that would be negative pi over 2, 2 pi over 2, 3 pi over 2. So the answer would be 1. At negative pi, we're here, so it would be 0. and negative pi over 2, it would be down here, negative 1. So I want you to continue to fill that. That would be for sine theta. And then after, you can use a graph paper to try to graph to see what it looks like. And then after, you can do the same with cosine. So if you do it with cosine, you're going to now use the first coordinate. So here at negative 2 pi would be 1. After it would be 0. After it would be negative 1. And finally here 0. And then keep going too for the rest here. And try to graph it. You can pause the video because on the next slide I will show you what happened. What does the graph look like? So when you're completing the table, you can find all the different values. It's going to look like this. So when you graph, it should look like this. Now, what's important for you to remember is that sine looks like this. So we're going to start here at 0, goes up, goes down, and then comes back. That's what sines look like. And cosine always starts at the top. It goes down, reach the bottom here, and then goes back up. So cosine is going to look like this. So these are the two images I would like you to remember. Cosine starts at the top, goes down and back up. Sine starts in the middle, goes up, down, and back in the middle. After, we're going to be looking at what happened when we add translation, reflection, stretching, vertical and horizontal in the next topic. Have fun!